Hello everyone, this video is about Chapter 6, Sampling Distributions. In Chapter 4 and 5, we assumed that we knew the probability distribution of a random variable, and using this knowledge, we were able to compute the mean, variance, and probabilities associated with the random variable. However, in most particular applications, this information is not available. Firstly, we will learn two definitions. A parameter is a numerical descriptive measure of a population. Because it is based on the observations in the population, its value is almost always unknown. For example, population mean, population standard deviation, population variance are parameters. A sample statistic is a numerical descriptive measure of a sample. It is calculated from the observations in the sample. For example, sample mean, sample standard deviation, sample variance, sample proportion, or like 2 plus 3 times sample mean are all called statistics. In a population, we denote the parameter population mean as mu, population standard deviation as sigma. They are parameters. Now, in a population, we can randomly select a sample. For this sample, we can calculate the average, the mean of this sample, denoted as x1 bar. We can randomly select another sample, and the mean of the sample is x2 bar, and so on. For the nth sample, we denote the mean of the sample as xn bar. Now, we only focus on all the means of each sample, and the means should have their own distribution, which we call sampling distribution of sample mean. We denote the mean of the sampling distribution as mu x bar. Denote the standard deviation of the sampling distribution, which is also called standard error of the mean, as sigma x bar. They are all statistics, which are measurements from a sample. Now, I will introduce a very important theorem called central limit theorem, which we can apply to solve real practical problems. That is, if the sample size n is bigger or equal to 30, then the sampling distribution of sample mean x bar will approximately be a normal distribution, with mean of this normal distribution equals to mu, the population mean, and standard deviation of this normal distribution, which is also called the standard error of the mean, equals to sigma divided by square root of n, which is population standard deviation divided by square root of the sample size n. The larger the sample size, the bigger or better will be the normal distribution. Now, we'll see how we can use z-table to apply it. We can use the z-score formula to transfer it into a standard normal distribution. That is, for the population, z-score equals the value x minus mean mu and divided by standard deviation sigma. How about the sampling distribution then? The same. Z-score formula is value minus mean from central limit theorem. Mean of the sampling distribution is mu, and then divided by the standard deviation. From central limit theorem, the standard deviation of the sampling distribution is sigma divided by square root of n. Now, by using z-score formula, we transfer it into standard normal distribution so that we can use the z-table now. How to apply? The sample mean variable of the sampling distribution is denoted as x bar. If n bigger or equal to 30, we can apply it based on the central limit theorem. That is, the probability that x bar bigger or equal to a number a. We can use the z-score formula, each side minus mean mu, and divided by its standard deviation, which is sigma divided by square root of n. Similarly, the probability that x bar smaller or equal to a number b, each side minus mu and divided by sigma divided by square root of n. The same as between two numbers a and b. Now, after calculate all the z-scores, we can use Chapter 5 materials using the z-table to find out probabilities. Z-score higher than positive or negative, lower than positive or negative, between two positives or two negatives, or one positive and one negative. Draw the curve and highlight the area. You will find out 0.5 minus the table value, or 0.5 plus the table value, or two table value add together or subtract. Please watch the part 2 video for examples. That's all for this video.